Assalamualaikum warahmatullahi wabarakatuh. My name is MAT455 and today I want to show you the solution for task 1, triple integral Cartesian coordinate. Given solid bounded region by the surface x equal to y square and the planes z equal to 0 and x plus z equal to 1 as in figure below. Okay, the graph shows the planes z equal to 0, it shows this plane z equal to 0. And the planes x plus z equal to 1, and this is the plane that showed. The x equal to y square, it shows this region. Okay, this is the 3D graph, and we want to draw it. This is easier to draw it using the 2D direction graph. Okay, from the x direction, this is x direction. How we want to draw the x direction is we ignore the x axis and only use z y plane. Okay, from the question we know x equal to y square and z equal to 1 minus x. From these two equations we know that x equal to y square, and we get z equal to 1 minus y square. Okay, if we let y equal to 0, we get z equal to 1. If we let z equal to 0, we get 0 equal to 1 minus 1 square, and y square equal to 1, and y equal to minus plus 1. From this graph, we know that z equal to 1 and y equal to 1 to negative 1 to 1. We know that negative 1 and negative y square is inverse c direction, but this is from x perspective, so the graph looks like Z face. From the y axis, we use the earlier equation z equal to 1 minus x, and the y axis is we look at the y direction and get at z plane. Okay, so we let z equal to 0, x equal to 1, and let x equal to 0 and z equal to 1. So the graph we made from the z and x plane, we know that z equal to 1 if x equal to 0 and z equal to 0, so x equal to 1. So we can get this graph just straight line. And the region, this is the region for the graph. So it will give the triangle graph from the y direction graph. Okay. For the z-axis graph, it shows the xy plane. So from the equation we get from the question is x equal to y square, and for usual we let x equal to 0 and y equal to 0. If we let x equal to 1, so y square equal to 1, y equal to plus negative 1. Okay, we know that y square is C shape look like in the graph, and we can show the graph is 1 to negative 1 region, and it must touch the 0, 0, 0, 0 graph, and we get the graph. From all three perspectives we get, from x-axis, y-axis, and z-axis, we can get the 3D perspective graph like this. This is the graph that I made in Desmos in my laptop, and this is the equation that I use to get this graph in the question. This is the 3D graph. Okay, on to the question. Triple integral Cartesian coordinate. Find the value of integral for each projection. So from x-axis, y-axis, and z-axis, we must find ds dy dz, dy dz dx, and dz ds dy. From x-axis, from the question we know x equal to 1 minus z and x equal to y squared. Ds dy dz, we must find x, we must find y, we must find z from integral. The integral dx dy dz, x we will find y at the middle and z at the last. So we must find x, y, z. X equal to 1 minus z and x equal to y squared equal to x, and y squared equal to 1 minus z, and last y equal to positive negative 1 minus z square, and z equal to 1 and z equal to 0. So from these three variables we put into the integral, and we must integrate each variable. First we must integrate x. This is 1 because there's no variable there, so we must put 1 and integrate x. Integrate 1 become x, and we must input the 1 minus z and x equal to y squared into the x, and we get 1 minus z minus y squared, and we must integrate y. After integrate y, 1 minus z, integrate y, just put y, and integrate y square, we get y cubed over 3, and must put the both of the equation into y. So if we want to easier, we must split the equation and integrate 1 minus z plus y, we get 2 times 1 minus z power of 3 over 2, and if we integrate y over 3 over 3, we get 2 over 3 times 1 minus z equal power of 3 over 2. So after we split it, we must integrate dz. Integrate dz is a bit complicated, so I use substitution. I substitute u equal to 1 minus z and du equal to negative dz. So I substitute 1 minus z equal to u and dz equal to negative du. So after I substitute it, it will become easier, and if negative du, the integral must be upside down, so 1 will go into 0, and if we reverse it normally again, 1 into 1, 0 into 1. So we just integrate u, and we get 2 over 5 u power of 5 over 2. So we must put 1 and 0 into u. So we get last answer is 8 over 15. From y-axis, dy dz dx. So we must find y, we must find z, and we must find x to put into the triple integral. So this is y, this is z, this is x, because dy, dz, and dx. So from this three variable, we can put y equal to negative square root x, and y into positive x, and 0 to 1 minus s, and 0 to 1. Okay, from 1 we must integrate y first, and we put this into y, and after that we get like this. So we must integrate z, and we just put z in there, and after integrate z we get x, and lastly we must integrate x. So after integrate x cos 1 to 0, and the last answer is 8 over 50. So lastly, we must integrate z exists. Z, dz, dx, dy. So we must find z, x, y. The question, z equal to 0, z equal to 1 minus x, and after that we must find x, and after that we must find y. So the question is z 0 to 1 minus x, x equal to y square equal 1, and y equal to negative 1 to 1. So we must integrate 1 dz and become z, and after that we put 1 minus x into z and 1 minus x, and integrate 1 minus x dx, and we get this, and after that we integrate dy, and the last answer we get is 8 over 50. Why the answer is same? Because it is the same space or the same volume. It will same volume. Although the volume is calculated using 3 different projections, the 3 different orders of integration, all methods give the same result, which is v equal to 8 over 15, because the region space is the same solid. The changing the axis of rotation only changes the order of integration, the limit. It does not change the actual volumes. So that's all from me. Thank you very much.